In algebra, one of the most basic relationships between two variables is a line. And what we'll be talking about in this video is how to make a visual representation of that line, something called a graph. So there are two basic methods out there. One is definitely called the slope-intercept method, and everybody calls it by that. The other one I'll call the two-intercept method. Some of it will say both intercepts. Some people will call it X and Y intercept method, so it's got a variety of names. But for this method, for the both intercepts, take your equation that is given to you, you plug in y equals 0, and you solve for x. That gives you the x-intercept. Then vice versa, you plug in x is 0 and you solve for the y, that gives you the y-intercept. You plot both of the points, and then you're just going to connect those 2 points with a line. Okay, the other method, first thing you do is you solve for y. If there's an x on the same side as the y, you move it to the other side. If there's anything on the same side as y, you move it to the other side of the equation. And if there's a number multiplied by y, you end up dividing by it. And you'll end up with y as some number times x plus another number. Now the number multiplying the x is called the slope, and the number that is added is the y-intercept. And you can do it the same way. If I put in here, like what it says over here, plug in y is 0. Plug in x is 0. If I plugged in x is 0, I would get y is m times 0. That's a 0. And then I get 0 plus b is b. So yeah, plugging in x is 0 gives me the b. If I follow these instructions over here on this, I would get b. Alright, once you've got that point, you plot it. Now you come back to the slope, that number in front of x. You look at that as a fraction. If it's not 1, if it's like a 7, you're going to write 7 over 1. If it's like 3.6, you're going to change that to 36 over 10. You'll reduce to 18 over 5. Okay, so you need a fraction. You definitely need to write it as a fraction. And then the numerator is the change in y. So the thing on the top is how much y changes, and the thing on the bottom, the denominator, is the change in x. Now, okay, you'll see that in some examples. That'll be more clear in examples. But starting at the y-intercept to move according to these changes, again, you'll see this shown in the examples. That gives you a second point. You already have the y-intercept as your first point. This now gives you a second point, and then connect the 2 points with the line. Okay, so I'll give 2 examples. Here's my first one. Here's an equation, and the fact that we just have x to the first power, or you don't see a power on x and you see some y's with no powers, that means it's going to be a line. And it's not x times y, it's something x plus something y equals, okay. You've got 3 things going on. One of them has x's, one of them has y's, and one of them is a number. That gives you a line. Under the two-intercept method, you see here, the x I made into a 0, and then that kind of dropped out because 0 times negative 3 is 0, and 0 plus 6y is 6y. So that just kind of went away. So give me 6y is 18, and then I divided both sides by 6. I didn't write that down, but that's how I got from here to here. I divided both sides by 6. That gave me y is 3. That's this point right here. Okay? So that was x is 0. I put in a 0 for x. So from the center, I do not move left or right. X is how far you move left or right. So I don't move left or right because x is 0. But y is 3, so I do go 3 units up. Now, I also need to put in a 0 for the y. You see that happening here. And that goes away, and I divide both sides by negative 3, remembering that a positive 18 divided by a negative 3, positive divided by negative is negative, okay? And that gave me this over here. That's where you have a point on the x-axis. X is negative 6, and remember y was 0. So y was 0, so I do not go up or down from the center. But x is negative 6, so I do move 6 units left. Those are my 2 points, and then I connect them with a straight line. Boom, there's my graph. And Okay, so here's the other way to do it. So I've got this here, and I want that y all by itself. So first thing I do is I added 3x to both sides. So ignore the 6's on the bottom. But I had 6y is 3x plus 18. Then the second step is, since I had a number in front of the y, I divided by that. So that's where you see the division by 6. So 6 divided by 6 is 1. So here you see 1y. 3 divided by 6 is 1/2, so you see 1/2 x. 18 divided by 6 is a 3. So the 3 is your y-intercept. Notice the same answer you got over there. And the 1/2 is your slope. So you plot the 3 on the y-axis. It's a y-intercept, so plot it on the y-axis. And then the top here, the numerator, is the change in y. So from this point, I will change my y by 1. I will move up 1 unit. Change in x is a 2. From there, I'll move to the right 2 units. Now, I could have done it the other way. I could have moved to the right 2 units and then moved up. I would have ended up in the same place. So it doesn't matter whether you do the y first or the x first. You end up in the same place. Then, having these 2 points, I connect them. Now, it looks like I might have slightly different lines here. I mean, the y-intercepts are the same, but it looks different. But you know what? If I drew a nice, perfectly straight line, and I extended this backwards, it would cross at -6. I'd get that point. And this point here, if I extended it far enough this way, I would see x is 2, y is 4, which is where this point is. See, x is 2, 1, 2, and then 1 up from 3 is 4. So that's the point. X is 3, y is 4. And if I extend this far enough to the right, I would see that. So they are the same lines. I'm just using 2 different points to draw the same thing. Okay, second thing. Oh, by the way, I want to come back here. This thing, in my mind, if it's in this format, call it a general format, or some people call it a standard format. In my mind, 2 intercepts works really nice if it's in this format. Now, okay, this format, which is called the slope-intercept format, if it's in the slope-intercept format, the slope-intercept method works really well. So let's go through slope-intercept first. Notice it's y equals. That's what tells me it's in slope-intercept method, slope-intercept form. Okay, so right away the number, and I don't have to solve for y, that's already done for me. The number in front of x is the slope, and I'm going to look at that as a fraction. So, even though it's -3, I'll say it's -3 over 1. And the number that's added on here, that's the y portion of my y-intercept. So x is 0, y is 9. So I start at 9. Here it is. And slope is -3 over 1. So I change y by -3. I decrease my y coordinate by 3. And I change x by 1. I increase my x coordinate by 1. So that puts me here, which is x is 1, y is 6. And then I connect the 2 points. Okay, so that's the slope-intercept method. The 2-intercept method, I've got this. I plug in 0 in for x. Excuse me, I plugged in 0 for y here. I will subtract 9 from both sides. Gives me -9 is -3x. I divide by -3. And then x is +3. Okay, and that's that point right there. And then I also need to plug in 0 in for x, and that becomes really nice. 3 times 0 is 0. 0 plus 9 is 9. I should have said -3 times 0 is 0. Plus 9 is 9. Okay, so that's that point up there. And then I got my 2 points, and I connect them. Done. Okay, so that is how to graph lines.